Welcome to a new lesson. In this lesson, we'll be solving problems involving more than one right triangle. Let's take a look at an example. In this problem, we're going to calculate the length of line segment CD to the nearest tenth of a centimeter. So let's take a look at this diagram. We are looking for we're looking for CD. And in this triangle, we have only this angle to help us the way. In order to find or solve a triangle, we need two sets of information: an angle and any side, or two sides. But we don't have those information. We only have an angle. If you look down below, we have another triangle, which is linked to the triangle that we have by this line segment BD. If we can find this green line or line segment BD, then we can use that information to find line segment CD. And in this triangle, there are two sets of information: an angle and a side, and we can use it to find the linking side between these two triangles. So that's what we're going to do. Our plan is we are going to find the green side, BD, line segment BD, then use line segment BD to find line segment CD. Always start off by having a little plan like this, and we'll work backwards to solve it. So we're going to start with SOHCAHTOA. And with respect to angle 47, label the triangles. So 4.2 is the opposite side, and the side that's linking the two triangles together is the hypotenuse. Why? Because the 90 degrees angle is looking at it. It's opposed to the 90 degrees. So we have opposite and hypotenuse. Hypotenuse we're looking for, so we're going to be using the sine ratio for this purpose. So the sine ratio of any angle is opposite over hypotenuse. Therefore, we're going to just plug it in. Sine of 47 is equivalent to the opposite side, 4.2, over the hypotenuse that we're looking for, or h. We're going to solve for this missing side by cross multiplication and by interchanging the hypotenuse with the sine 47. I'm going to plug this into your calculator, make sure you're in degree mode, and we get a hypotenuse of 5.7428 centimeters. Notice in this situation, we don't really care about that the question is asking into the nearest tenth, because we're going to be using this number further to calculate our CD. We're going to keep as many decimals as possible to make sure that the answers are accurate. So now let's focus on the line segment CD. We know that now BD is 5.7428. We have an angle. We have to relabel the triangles. We know that 5.7428 is the hypotenuse of this triangle because 90 degrees is looking at it. And the red line, the CD, is the adjacent side of the triangle. So now instead of or sine, we're going to use cosine to find line segment CD, because we're looking for adjacent and we have hypotenuse of this triangle. So we're going to do it on the side. So cos of any angle is the adjacent side of hypotenuse. Now we're going to plug in the specific values. Cos 26 is adjacent, that's what we're looking for, over hypotenuse. Still solving for A, we cross multiply. That means we're moving the 5.7 and multiplying the cos 26. So we'll get 5.7 cos 26 is equal to our adjacent side. Now if we're going to measure, I'll use red because I've drawn line segment CD as red. So when you plug this in your calculator, make sure you're in degrees mode, we get A, or line segment CD, of 5.2 centimeters. And this is your final answer. Let's take a look at another example. From the top of a 20-meter high building, a surveyor measured the angle of elevation of the top of another building and the angle of depression of the base of that building. The surveyor sketched this plan for her measurements. Of her measurements. Determine the height of the taller building to the nearest tenth of a meter. So here's your picture. A couple things to note before we set the question. What is the angle of depression and what is the angle of elevation? The angle of elevation is the angle between the top of the building, of the small building, to the height of the big building. While the angle of depression is from the top of the building, of the small one, to the base of the second building. So that's your angle of depression. So using these angles and the height of the small building, we should be able to solve for the height of the tall building. In this question, there are two triangles involved. First is the small triangle, and then the large. We're going to focus on the small first. What you must know is that this 90-degree angle that's in the big triangle is also there's also a 90-degree angle in the small. And what I'm going to do is I'm going to draw this small triangle, a little bit enlarge it for you so you can see it better. And what do we know about the angle of depression? Is 15 degrees. And we also know this height. Oh, I don't like to use orange too much, so I'm just going to start using blue. So this is actually also 20 meters. Why is it 20 meters? Because this side right here is also 20 meters. So that has to be 20 meters as well. And the next part is, well, how do we find the height of this building? There's something we have to do. What we have to do is we have to find the common side to both these triangles in red. If we find this common side, then we can find the height of this triangle. And if we find the height of that triangle, we add it to 20, and there's the total height of our building. So let's find the common side of these two triangles, the shared side. And again, SOHCAHTOA is in order. SOHCAHTOA will tell us which trig ratio we could use. We know that 20 meters height is the opposite side of the triangle, the opposite side of the 15 degrees. And the shared side, or the common side, the red, is the adjacent part of this triangle. So we know that we have opposite and we're looking for adjacent, therefore we have to use the tan ratio. So let's use the tan ratio. Tan of unknown angle is opposite of adjacent. It's always good to write the formula. Tan of 15, now we plug it in, is opposite, which is 20, and we're looking for the adjacent side, which is A. Now, next part is that we can interchange tan 15 with A, and we'll cross multiply. To get A over 1 is 20 over tan 15. This means that we get a value of 76.6410 this case meters. Now we can use that value to find the green or the height of the second triangle. So I'm going to redraw the larger second triangle, and we know that the bottom one is 76.6410 meters. We also know that it's 30 degrees, and now we're looking to find the opposite side of this triangle, while the side that we found was the adjacent side. Again, using SOHCAHTOA, we find out that we have to use the 10 ratio again, because we have adjacent, we're looking for opposite side. So again, we rewrite 10 of any angle is opposite of adjacent. 10 of, we plug it in, 15 degrees is, sorry, not 15 degrees, but 30 degrees is opposite over 76.6410. Then we cross multiply because we're solving for opposite. I'm just going to keep on working here. Opposite is equal to 76.6410. 10. Let me erase this because there's no space and rewrite it. 30 degrees is equal to opposite. Therefore, the opposite side is equivalent to 43.0940 meters. Now, don't think that this is actually the height of the building altogether. You see, the building was composed of two triangles. We know that this 43 meters is for this part, the top part of the triangle, but the bottom part was 20. So what we have to do is we have to add these two values together. And we're going to add them right here. So the sum is 43.094. Notice that I'm keeping all the decimal values. I'm going to add it to 20. And we get the final answer. Now this is where we round off to the nearest tenth of a meter, is 63.1 meter. And this is your final answer, the final height of the building. So it's a three-step process in this case. Let's take a look at our very last question. From the top of a 90-foot observation tower, observes one fire due west of the tower at an angle of depression of 5 degrees, and another fire due south of the tower at the angle of depression of 2 degrees. How far apart are the fires to the nearest foot? The diagram is not drawn to scale. So let's take a look at the diagram and the missing information from the diagram. We know that the tower is 90 feet tall, and that the angle of depression is 5 degrees for one fire, and the angle of depression for another fire is 2 degrees. The question is asking is how far are the fires from each other. What's missing from the question is that the idea is that there's a bottom triangle that are made that has a 90-degree angle, and the finished right angle triangle. So the question is being asked, what is the distance between them? If we can find the distance from the tower to one of the fires, and distance from the tower to one of the fires on the ground, then we can use Pythagoras to find the distance between the two fires. What's also missing is that in this question, we know the angle of depression, but we do not know the angle of between the line of sight of the tower to the tower itself. And that angle is the difference between 90 and 5. So we subtract 90 minus 5, and that angle here turns out to be 85 degrees. We do the same thing on the other side, 90 minus 2, and this angle right here turns out to be 88 degrees as well. That's a little bit unclear. What I'm going to do is I'm going to redraw this picture having the 85 and the 88 degrees together. What also is important when you draw this picture is that you have to know that the tower itself is at 90 degrees to the fire, one of the fires, and also 90 degrees to the other fire. There you go. So now we have actually 3 right angle triangles. The first stage is to find the green distance from the tower to the fire itself. How do we do it? Well, first we label the triangle. We're going to take a look at the left triangle, the 85 degrees first. We know the angle is always looking at the opposite side. So this is the opposite side. And what we want to solve for is the opposite side. And we also know that the tower itself is 90 feet. That is the adjacent side of the triangle. So again, we're going to make sure you always write down SOHCAHTOA. And the only trig ratio that has O and A in it is, of course, tangent. We're going to use tangent to find this opposite side, and distance from the tower to the first fire. And I'm just going to write this is the first and this is the second fire. So again, tan of 85. I'm just going to kind of do a little shortcut because I already know that it's opposite of adjacent. And we're looking for the opposite side, and I know the adjacent side, which is 90. We're going to cross multiply and bring the 90 feet up. So we'll get 90, 10 of 85. That is equivalent to the opposite side that we're looking for. That's one of the distances of the fire. And the opposite side is equal to 1,028.705 meters. So that means this opposite side is 1,028.705 meters. Now we're going to do the opposite. We're going to, not the opposite, but we're going to solve for the distance from the tower, base of the tower, to the second fire. We're going to use the same idea. We're going to label the triangles. So we have, again, opposite. The tower height is still 90, and we're going to use the 88 degrees. So now tan of 88 is equivalent to the opposite side divided by 90, and again cross multiplied. We get 90 tan 88. We're going to get a very large distance as well. And that distance turns out to be 2,577.26 meters. I'm trying to keep as many decimals as possible. So that means this distance from the base of the tower is 2,577.26 meters. Now what's remaining is the distance itself from the two fires. So notice we have a right angle triangle at the bottom. We can use Pythagoras to solve our question, and it's a good practice for you to always write the formula. Try not to use the shortcuts. So c squared equals a squared plus b squared, and we're looking for the hypotenuse, the longest side, so that's c squared And we're going to use now the values that we obtained in previous 10 ratios and the 2577.26 meters as well, squaring it. So we're going to continue right here. So that means C, you have to take the square root of everything that you see in the box, and we will get the distance between the fires of 2,775 and it's in feet. Oh, so also double check that your answers have the right units and that your solution has the right units. And I think I've been using meters somewhere, so I'll make sure that I fixed my mistakes so that we are using feet instead of meters. And that's the distance, and it does make sense, at least to me, because the hypotenuse, the C side, the distance between the two fires, the 2,775 feet that we just calculated, is longer than any of the other sides of the triangle which are not the hypotenuse. So that does make sense to me in this case.